So here's a look at the first two questions from the Chapter 2 practice questions. And so the first one asks you about the number of protons, neutrons, and electrons in several different atoms, and we want to calculate those. So just to review, the very first things we need to keep in mind is that if you have an atomic symbol, if there happens to be a number located as a little subscript right here, this would be the atomic number. But oftentimes the atomic number is not going to be written there. And so you might need to look at a periodic table to actually get that information. So I would recommend that you have a periodic table in front of you now, because if you don't, you're not really going to be able to complete these questions. Then if we have something located up here at the top, this is going to be where we have our mass number located at. The mass number is always equal to the number of protons plus neutrons. And so that's valuable information if we need to figure out the number of neutrons. And then over here on this side, as a superscript, this is where we would find the charge located at. And if you don't happen to see anything located there, then we can assume that the charge is going to be neutral, or in other words, the charge would be 0. Okay, so keep that information in mind as we go through and we start taking a look at these questions. Okay, so if we look at the first question, hydrogen, if we want to figure out the number of protons that it has, we're going to need to look at the atomic number on the periodic table because it's not shown in this question. So if we do look at a periodic table, here's just a snapshot of mine, and you can see that in the very top of the hydrogen box there is a 1 there. That would be the atomic number for hydrogen, and the atomic number is always equal to the number of protons. So what that's telling us is that for hydrogen we're going to have 1 proton. Next, if we want to figure out the number of neutrons, we're going to look at the mass number, and the mass number in this case is 1. So if my mass number is equal to 1, then that tells me that the number of protons plus the neutrons is 1, and we've already solved that we have 1 proton here. So if this is what we're dealing with, we solve for n, and that means that n is going to equal 0 in this case. So we actually have 0 neutrons, so it's very possible for an atom to not have any neutrons present. And then if we want to figure out the number of electrons, we're going to look at the charge. And if you look at this example, there's no charge listed there, so the charge is going to be 0. So the charge is equal to 0, and that would be the protons minus the electrons is going to give us that charge. So we have 0 equals 1 for the number of protons we've already calculated, minus E, and so E is going to be equal to 1. So in this one, we have 1 electron here. Okay, so that's how we would solve the very first question. So if we look at the next one, it's still hydrogen, so we're still going to have 1 proton there. We have a different mass number. The mass number is 3, and remember that that 3 is equal to the number of protons plus neutrons, and again, we've already solved for the number of protons, so we're really just solving for n. So n is going to be equal to 2, so we have 2 neutrons. And now this time we have a plus 1 charge. So if you just see the plus sign there, we assume that there is a 1 next to it. So if the charge is equal to plus 1, and that's equal to the number of protons, which we know is 1, minus the electrons, and we solve for the electrons. The electrons in this case is going to be equal to 0. So it is very possible that we have 0 electrons present. Okay, so that would be the second question. If we look at C, and I'm just going to move down a little further on my diagram here. So nitrogen, if we want to figure out the number of protons, again we would need to go to the periodic table and figure out what the atomic number for nitrogen is. So take a look at your periodic table. Okay, here's mine. So moving over here, here's my box for nitrogen. I can see that nitrogen has a 7 in the top, which means that nitrogen is always going to have 7 protons. So I've got 7 protons. If I want to figure out the number of neutrons, I'm going to use my mass number. So here's my mass number. Mass number is equal to 13. So 13, the mass number is equal to the number of protons, which is 7, plus n. Solve for n. That means we have 6 neutrons in this case. And then for the electrons, notice my charge is -3 or 3 negative. Same thing. So if the charge is equal to -3, it's equal to the number of protons, which is 7, minus the electrons. Solve for your E. So if we solve for E, we're going to end up with 10 electrons here. Okay, so hopefully you're getting the hang of it, understanding that you've got to use your periodic table to figure out what the number of protons is. Look in the top of the box to get that atomic number. Use the mass number here to figure out the number of neutrons, and then when you're ready to figure out the number of electrons, you're going to need to look over here at that charge that we have present. Alright, so I've just cleared everything off to clean this up just a little bit. If we look at the very next one, calcium, we want to look at the periodic table to see what its atomic number is. So again, if we take a look at the periodic table, calcium's going to be over here. Notice that we have a 20 at the top of the box. So that means that the atomic number is 20, and more importantly, it means that it has 20 protons. So we know that. If we want to figure out the number of neutrons, we're going to look at the mass number here. So we know that the mass number 38 is going to be equal to the number of protons, which we know is 20, plus the number of neutrons. So solve for n. If you do that, n is going to be equal to 18. So we know we have 18 neutrons. And then if we solve for a number of electrons, we're going to be looking at the charge right here. So based on the charge, we know that the total charge, 2, is equal to the number of protons, 20, minus the electrons. And if we solve for E, that's going to equal 18. So we have 18 electrons. Now, as you're figuring out the number of electrons, keep in mind that if you have an overall positive charge, there should be more protons than electrons. If you have an overall negative charge, there should be more electrons than we have of the protons. If we look at the next one, lithium, to figure out the number of protons, again, it's back to the periodic table. So lithium has a 3 at the top, so lithium has 3 protons. So we've got 3 protons here. We would use the mass number here to figure out the number of neutrons. So we know that 6 is equal to P, which is 3 plus N. So N is going to be equal to 3. So we have 3 neutrons. And then if we're figuring out the number of electrons, we have a plus 1. So if I just write it up here, plus 1 is going to be equal to the number of protons, which is 3, minus E. So if we solve for E, E is going to be equal to 2. So we have 2 electrons. On F, figure out the number of protons for iron. So we'll locate iron on the periodic table. Iron is going to be right here, so it's number 26. So we've got 26 protons. For the number of neutrons, we take our 57 here. So 57 is equal to the number of protons, which is 26 plus N. So that's going to be equal to 57. So solve for N. So what that means is that we've got 31 for our neutrons. And then when we calculate the number of electrons, the charge is 2. So we're going to say plus 2 is equal to the number of protons, which is 26, minus E. Solve for E. When we solve for E, E is going to be equal to 24. So we have 24 electrons. And then on the last one here, Kr. Okay, so if we look that up, find it on the periodic table. It's going to be way over here, krypton. Krypton has a number of 36, so 36 protons. To solve for the number of neutrons, remember that we're going to take the mass number. Mass number is 81, so 81 is equal to the number of protons plus neutrons. Solve for N. N is going to be equal to 45. And so we have 45 neutrons. And when we look at our charge, the charge, since we don't see anything here, the charge is 0. So you can assume there's a little 0 there. Anytime there's a 0 charge, that means that you have the same number of protons as you have electrons. So it is going to be 36 electrons. We could still set it up the other way if we wanted to. The charge is 0 is equal to the number of protons, which is 36, minus E. So E would still be equal to 36. Okay, so that's a quick run through of how you would solve all of those number 1 questions. Question 2 is going to be easier really than question 1 was. So in question 2, we're looking for just the atomic number and the mass number for each of these listed molecules. Recall that the atomic number is the top of the box. on the periodic table. And then when we're talking about the mass number is the superscript that you have next to the symbol. So in other words, something like this. So if we go through and we look at these quickly, the first one, molybdenum, if we find that on the periodic table, molybdenum is going to be right here. So that is an atomic number of 42. So we'll write 42 here for its atomic number. As far as its mass number goes, that's right here, the superscript. So that's going to be 98. The next one, barium, we look that one up. Barium is going to be right here. So number 56 would be its atomic number. So we'll write 56 here. Its mass number is right here, 135. Potassium, the atomic number we can see right here would be 19. And then its mass number right here, 38. And then the last one that we have, this would be mercury. So if we look up mercury, mercury is going to be right here. So mercury is an atomic number of 80. And it has a mass number of 205.